PSC1-4 covers indirect measurement in word problems. So indirect measurement is when you are using similar triangles to calculate height of objects you can't reach. So rather than measuring the height of the building, I'm going to measure the shadow of the building in my height and my shadow. Okay, that kind of scenario. There are two different ways you can do this. The first one is the one I just talked about, the shadow method. So if you're outside and you have a sunny day and the sun is bright enough, you'll see the shadows really distinctly, and you can make two triangles. Okay, so we've got my triangle here. That will always be similar to the triangle being made by whatever tall object you're using, because that's how the sun works. This doesn't work inside because you don't have the sun. You need one source of light. Inside, you have multiple sources of light. Now, if you were able to go to a room that was dark enough and you had a singular light that was bright enough and no other sources of light, then yes, it would work inside. But those situations are few and far between and take a lot of setup. When I'm doing a problem like this, though, I can say my little side A to my little side B, so from this triangle, equals big side A to big side B, that triangle. And I can solve that proportion for whichever piece I'm missing. Usually it's the height of whatever tall object. The mirror method works inside or outside. So in this case, you end up with a triangle AB on this side and a triangle on that side where A and B kind of fold into each other. So the idea is you're setting your mirror on the ground. You're going to back up until you can see the top of whatever object in the mirror. Okay? Then you're going to set up your proportion of your distance to the middle of the mirror to the height to your eyes. The tricky thing here is I'm 5'8", but my eyes are not 5 feet 8 inches above the ground because they're in the middle of my face. They're not at the top of my head. So it's important that you measure up to your eyes so you know exactly how tall you are, or how tall your eyes are, rather. Then you're going to measure the height or the distance from the mirror to directly underneath whatever object, and then you can solve for the height of the object. All right, so we're going to do some examples with this. You're at an indoor climbing wall. You want to estimate the height of the wall. You do the mirror method. You end up 85 feet from the base of the wall. So here's my wall. We're going to put the mirror here. We'll make it black. This is 85 feet. Okay. Then you're walking backward until you can see the top of the wall in the mirror. And you end up 6.5 feet away. Here you are. Those are your eyes. Your eyes are 5 feet above the ground. So we have a triangle here where 5 and 6.5 are one side of it. 85 and this unknown x are the other side, or the similar side rather. And I can solve a proportion. So I have your eye's height over the distance to the mirror equals the wall's height over distance from mirror to wall. I'm going to cross multiply and divide, and I get that x is 85 times 5 is 425 divided by 6.5. That wall is 65, we're going to call it 65.4 feet. Similar problem, you're at the Eiffel Tower. You want to know how tall it is, but you don't speak French, so you can't ask anyone, but you did remember to bring your mirror and your measuring tape, which is really convenient. So, we want to figure out how tall the Eiffel Tower is. The Eiffel Tower, so my question mark, over distance from the Eiffel Tower to the mirror will equal your height over distance from you to the mirror. Again, we can cross multiply and divide. So 1728 times 1.5 divided by 8. Eiffel Tower is about 324 meters. You are actually going to do this on your own for your project for this unit. So you can either borrow my mirror, you can use a mirror you have at home, or if it is sunny out and you find a time to go outside, you can do it with shadows. You can work with up to one other person. There are more details about this assignment on Schoology.